Good morning, students. I am Mahesh, mathematics lecturer. Now I am going to explain a beautiful concept called matrices. Okay. So what is matrix? First, matrix is a rectangular arrangement of numbers or functions. Okay. So actually, any matrix can be represented as by using the capital letters. Okay. For example, A, B, C, D like this. So let us take one example. A is equals to 1, 2, 3, 4 and B is equals to sin x, cos x, x square plus 1, 3 like this. This is also one matrix. This is also one matrix. Okay na? So matrix is a rectangular arrangement of the numbers. Okay. So next we'll move to the order of the matrix. How to know order of the matrix? Okay. Order of the matrix. Order of the matrix. Order of matrix. Okay. Let us take one matrix. Let us take one matrix. 1, 2, 3, 4, 5, 6. Let us consider this is one matrix. Here, how many rows are there? See, so first you have to know rows and columns. Rows means this is first row. This is first row. Okay. This is the second row. Here, it contains, this matrix contains 2 rows. That's 2 rows. Okay. So columns, how many columns are? This is first column, this is second column, this is third column. How many columns are there? 3 columns are there. So we can represent order of this matrix is 2 by 3. This is called the order of the matrix. Okay na? So what is the generalization for the order of the matrix? First have to calculate the number of rows in this matrix and have to calculate the number of columns in that matrix. Then we can write. So let us consider if a matrix contains m rows and n columns, then the order of the matrix is it can be denoted as m by n. Okay, it can be read it as m by n. Okay, this is the order of the matrix. Let us consider another example. So see, let us see. 1, 2, 3, 4. This is another matrix. See, what is order for this matrix? Here, see how many rows? 2 rows are there. 2 by. Okay. How many columns are there? Total 4 columns are there. So, order of this matrix is 2 by 4. Okay. So, this is the order of the matrix very easily. Next, we will move to the next concept called different types of the matrices. What are the different types of matrices? We have different types of matrices. First, okay, first matrix is column matrix. Column matrix. Okay. The word itself tells column. Column matrix means what? First, already discussed about the matrix, no? So, column matrix is what? A matrix is said to be a column matrix if it has only one column. Only one column. Means, let us take one example. Say, A is equals to 3, 5, 6. See, here only one column is there. But it contains how many rows? It contains 3 rows. 3 rows and 1 column. See, this is first row, this is second row, this is third row. This is 1 column only. So, 3 rows and 1 column. So, it contains only 1 column. So, we can tell that type of matrix is known as column matrix. Okay na? So what is the generalized form of the column matrix means? So we can write if you take another element 3, 5, 6, 7. So it will become 4 by 1. Okay. If we take another element, it will become 5 by 1. Okay. But the column is same. Rows are changing. That's why what is the general form of the column matrix means m cross 1. So this is the general order of the column matrix. M depends upon the rows of this column. Okay na? So this is the column matrix. Next we will move to the row matrix. What is row matrix? Row matrix. Okay na? So it is just opposite to the column matrix. So what is row matrix? Row matrix is said to be a matrix is said to be a row matrix if it has only one row. Okay, it has only one row. Let us take one example. A is equals to 4, 5, 7 like this. See, it contains only one row, but it contains 3 columns. So we can write what is the order of this matrix, this row matrix. It contains only one row. That's why we can tell that this matrix is row matrix. So what is the order for this one? One row and number of columns are 3. 1 cross 3. 1 by 3. We can tell that. So what is general order for the row matrix is 1 cross n. So this is the, so number of rows will be 1 only. Number of columns can be changed. Okay na? So this is the row matrix. Okay, let us move to the next concept called, very important concept called diagonal square matrix. Square matrix. Okay, so the word itself tells what is square. Actually square means all sides are equal, no? So here also, so similar to that one, matrix is there, no? Here square matrix. Square matrix is what? A matrix is said to be a square matrix if it number of rows is equals to number of columns. That type of matrix is known as a square matrix. Let us take one example. By example we can come to know whether it is square matrix or not. See, so let us take 4, 5, 6, 7, 8, 9. Okay. See, how many rows are there? Here 2 rows are there. How many columns are there? 3 columns are there. This is not a square matrix. In order to make square matrix, okay, so how to make this one square matrix? See, let us consider two rows and 2 columns. See, so here 2 columns are there. So 2 rows are there and 2 columns are there. The order is 2 by 2. So therefore we can tell that this is square matrix. Square matrix is what? Square matrix, in a matrix in which the number of rows are equals to the number of columns is said to be a square matrix. This is a 2 by 2 square matrix. Let us consider another 3 by 3 square matrix. Okay, this is 3 by 3. Why? Because 3 rows are there, 3 columns are there. That's why this is called as 3 by 3 square matrix. Okay na? So by using the square matrix we will discuss one important concept. Okay, what is that important concept? Means diagonal elements. Okay, diagonal elements. What is diagonal elements actually means? Okay, first if you write this matrix like this means, see, let us consider one matrix is like this: A11, A12, A21, A22. I will write as a elements. Why? Because I wrote like this means A11 means the element A11, it contains in first row and first column. See, 4 in first row and first column. Okay, 5 in first row and second column. That's why A12. This is A12. Okay na? So this is A21. A21 means what? Second column, first row. So A21 this is. A22 means second row, second column, like this. This is A11. This is A12. This is A13. Okay. A21, second row, first column. A22. A21, A22, A23. A31, third row, first column. Okay. A32, third row, second column. A33. Okay. Third row, third column. Okay na? So what is the use of this one, sir? So diagonal elements. Diagonal elements means in any square matrix, the elements call it as A11, A22, A33 and so on. ANN are called the diagonal elements of this square matrix. We can tell that. Okay. What are the diagonal elements of this matrix means 4 and 8 are the diagonal elements. Actually, you can easily tell that diagonal. So if you take one square like this is diagonal, no? Okay, like this is also diagonal. We will sometimes call it as principal diagonal. That's why we are taking this only. Okay, na? A11, this is A11, this one. A22, see this one. Okay, na? So what is the diagonal elements for this one? These three are the diagonal elements. A11, A22, A33. So diagonal elements means 1 same, it should be same like this. Okay, na? Diagonal elements, these are the diagonal elements. By using this diagonal elements information, we will explain. Okay, I will explain three definitions. Very important, three definitions. See, first definition, very important for our main examination. Okay, diagonal matrix. Diagonal matrix. Okay, what is diagonal matrix actually? Okay, let us take a square matrix is said to be a diagonal matrix if all non-diagonal elements are 0. This is a definition for the diagonal matrix. This is very important for the 1 mark question. Okay, so let us take one matrix. See, 4 0 0 0 5 0 0 0 7. So this is one diagonal matrix. Okay, so how it will be diagonal matrix? See, this is the diagonal elements. No, these are called the diagonal elements. Okay, diagonal matrix. A square matrix, this is a square matrix, so number of rows and number of columns are same. Okay, square matrix is said to be a diagonal matrix if non-diagonal elements are 0. See, these are the diagonal elements. No, 4 5 7 are the diagonal elements. Non-diagonal elements are there, so all are 0. So our non-diagonal elements are 0. Then we can tell that this type of matrix is diagonal matrix. Okay, na? So and we will move to the next matrix called scalar matrix. Okay, scalar matrix. Okay, so we are giving some additional information to diagonal matrix. We can consider to be a scalar matrix. What are the additional properties to be? Means let us consider the same matrix. Say B. We are considering as a B. Okay, so I am writing like this: 4 0 0 0 4 0 0 0 4. By observing only, we can easily tell that what is the definition of this scalar matrix. Scalar matrix, a square matrix is said to be a scalar matrix if non-diagonal elements, see, non-diagonal elements are zeros and diagonal elements are same. We can tell that like that, scalar matrix. Otherwise, another definition is there. What is another definition? Means scalar matrix, a diagonal matrix is said to be a scalar matrix if diagonal elements are same. Why? Because scalar matrix, if we tell the scalar matrix, all diagonal properties will be satisfied. That's why scalar matrix is said to be a diagonal matrix is said to be a scalar matrix if all diagonal elements are same. Here, so we have the two properties. One property is all diagonal elements are same and all non-diagonal elements are 0. What is the difference between diagonal matrix and scalar matrix? Means here one similarity is there. What is one similarity? Here non-diagonal elements are 0, here also same. Okay, this is one similarity. What is the difference between these two things? Here all diagonal elements are may or may not be different. Here all non-diagonal elements, diagonal elements should be same. All diagonal elements should be same means scalar matrix, different means diagonal matrix. Okay. All diagonal matrices are not scalar matrices, but all scalar matrices are diagonal matrices. Okay, na? So we will discuss another last concept is called identity matrix. Okay, I will change see, I will write instead of 4 1. Okay, here 4 1. Okay, here 4 1. Okay. This is called identity matrix. How? Identity matrix. What is identity matrix? A square matrix is said to be identity matrix if all non-diagonal elements are 0 and non-diagonal elements are 0 and diagonal elements are equals to 1. Okay. So So first had understood the difference between diagonal, scalar and identity matrix. Okay, identity matrix. Okay, just take this 4 only. Okay, so so 1 0 0 0 1 0 0 0 1. See here, what are the similarities to these three means non-diagonal elements are 0, non-diagonal elements are 0, non-diagonal elements are 0. Diagonal elements are different, diagonal elements are same, diagonal elements are same and equals to 1. Okay na? So all diagonal matrices are not scalar matrices and identity matrix. Okay, all scalar matrices are not identity matrices. Okay, but all identity matrices are scalar matrices and diagonal matrices. Okay na? All scalar matrices are diagonal matrices. Okay na? These are very important for examination. Thank you, my dear students.